Okay, we should find the value of predicted y for each of the observation first using the equation that we have just now. Just replace all the x in this equation, then you dapatkan nilai predicted of y. Okay, I dah masukkan kat sini. Actually, I guna Excel. Lagi senang lah kalau guna Excel kan, you can drag sahaja. Just create the formula and then you just drag all the value of predicted y. Kalau tak, kalau dalam exam kan, you guna calculator. So actually dalam calculator pun boleh kan create the equation. You boleh gunakan alpha dan juga calculate kan. Alpha tu kan yang color merah tu kalau you punya ni. Kalau you punya calculator, scientific calculator, let's say kita buat 0.6636, which is the equation here. Okay, plus 0.7213, and then nak letak x kat belakang tu. X tu you ambil yang alpha. Alpha yang warna merah tu kan. Alpha x. X pun ambil yang warna merah dalam yang bracket. Okay, alpha x. Then tekan calculate. Bila you tekan calculate, dia keluar x tanda soal kan. So you masukkan value x 0.83. The answer will be 1.2622. Kalau you nak pula yang second one, tekan balik calculate, dia akan keluar balik x tanda soal, question mark. So you masukkan pula yang kedua, x yang kedua 1.22, tekan equal, dan dia keluar dah a value 1.5435 here. Okay, and then yang ketiga nak cari the next y predicted. Yang ketiga, tekan balik calculate, dia keluar balik x question mark. So you masukkan x yang ketiga 1.48 then equal, then you get 1.7310. Then you can do it again for each of the x here, then you akan dapat this column. Sama juga untuk the second group, gunakan the same equation. Okay, the same equation, then replace x here. Dalam equation, you akan dapat predicted of y. Okay, lagi senang sebenarnya kalau gunakan Excel. Okay, but kalau nak buat manually, kena guna calculator lah. Okay, to find the residual, it is yi minus y hat. So this column, okay, this column minus dengan this column y predicted, you akan dapat 0.3378 here. Okay, you can do it one by one. Okay, kalau dalam Excel lagi senang lah, kita boleh buat one by one, just drag saja, you akan dapat all this column. Sama juga dengan yang ni, it should be this column minus dengan this column, you akan dapat the residual. Okay, after we have the residual, then you need to find the median for each group. Okay, you have to find the median of the residual for each group. Okay, so you tahulah macam nak cari median, kena you have to arrange the residual first to find the median, which is the median adalah titik tengah. So kat sini, if the observation is 11, so dia punya median will be the 6 observation, right? 6 residual. Okay, residual yang ke-6. So just tengok one by one. So yang ke-6 will be negative 0.108. Okay, sama juga the next one for the second group pun sama. You kena cari the median for the second group. Okay, here because of the observation is 9, so the median will be position yang ke-5. So the value will be 0.1964. Okay, so we need that median of the residual for each group in order to find the value of D. Kan? D adalah the deviation, absolute deviation of the residual about their median. Okay, deviation between the residual and its median. So for each group, kena kira dua-dua. Okay, so you kena buat satu-satulah. So saya dah buat dalam Excel. Okay, just nak tunjuk contoh, nanti boleh buat and then check dia punya answer here. Untuk dapatkan D1, so sini DI ni, this column. D1, just the absolute value of the residual minus dengan the median tadi. Negative 0.108. Okay, so you need to do each of the observation here. Sama juga dengan yang kedua. Group yang kedua, sama juga untuk dapatkan D2. So, absolute of the residual minus dengan its median, which is the median adalah negative 0.1964 for each of the observation. So, you akan dapat this column. Okay, so itu untuk dapatkan D. Okay, so the next one, we also need to find the here DI column of D1 minus D1 bar square. Sebab nak cari S pool, kan? The variance pool, so kena cari D1 bar first. So kena carilah D1 bar, which is how to find the D1 bar here. Summation of all the D divide dengan how many observation in the current group. Okay, kalau kat sini bahagi dengan 11 lah. Sama juga untuk D2 bar, kena total up this column and then bahagi dengan 9, and 2 is 9. Okay, so once we have the D1 bar and D2 bar, we can find the column of D1 minus D1 bar square. Okay, this column, like I said this now, this column. Okay, so cari satu-satu, squarekan dia. Saya dapat dalam Excel. So the F3 here, this column, minus dengan D1 bar, dan squarekan dia. So you akan dapat this column. Total of this column, this is the total of this column, will be the summation of D1 minus D1 bar square. Okay, yang kita akan gunakan to find the S pool, S square pool. So sama jugalah dengan the next group. You need to find this. Squarekan dia. Total of this column, you akan dapat summation of DI2 minus D bar 2 square. Okay, so we need all this value to calculate the S square dan juga T. Right? So let's say we have all the value. So then we can continue with the hypothesis, which is H0 adalah the variance of error is constant, and then H1 the variance of error is not constant. Okay, so dia punya test statistic will be T, Brown Forsythe test. D1 bar tadi berapa dapat? D1 bar, we have 0.25. Okay, 0.2536. 0.2536. Okay, 0.2536 minus dengan D2 bar adalah 0.2057. 0.2057. Okay, divide dengan, yes, kita tak kira lagi value of S tadi. Kena kira dulu value of S. Okay, summation of D1 minus D1 bar square adalah 0.2154. 0.2154. Okay, plus for the second group 0.3634. 0.3634 divide dengan n minus 2. So how many n that we have is 20, right? So it is 18. So the answer will be it will be 0.4235. So here 0.4235 multiply dengan square root of 1 divide 11 plus 1 divide 9. So what we have here, okay, we got 0.2516. Okay, so we have the T brown forsythe is 0.2516. Then we need to compare this with the critical value from T table, which is T 0.05 0 1 and 18. Okay, so it is 1.734. You can check using your table, statistical table. So because of the T value is 0.2516, okay, 2516, which is, okay, cantik kat sini. Okay, 0.2516, which is less than the critical value 1.734. So we fail to reject hash note. So we can conclude that the variance of error is constant. Ataupun the homoscedasticity assumption is achieved. Okay, so that is the way how you conduct the brown forsythe test to check whether the variance of the error term is constant or not. Okay.